For this next video, we have another trigonometric function. This time, we have here cosine z, and we are going to show that its derivative is negative sine z. Take note that this is already true for the real numbers. We also have a video for that in our the calculus playlist showing that that is true. But this time, let's also show a different version, or I mean similar version, just by using z instead of x, because z stands for any complex number. Now, we know that there is a definition for the derivative of a certain function. We have here the limit of your f of your z plus delta z minus your f of z all over your delta z as your delta z approaches 0. Let's use this definition in proving this, okay? And then we are to provide here this expression and later on apply some processes or important identities to remove this as well. So since our function f of z is cosine z, that would mean f of z plus delta z would be equivalent to cosine of z plus delta z, okay? That is its equivalent form. So, continuing with our proof here, this is equivalent to the limit as delta z approaches 0 for your first function. That's cosine of the sum of z and delta z. And you have here cosine z as our first original function. These are all over delta z. Please remember that we cannot simplify this yet because this is again 0, or it approaches 0, and we can no longer add them automatically because they have different components. What we can do here is actually provide us with equivalent form of the first function of the numerator, which is equivalent to the sum formula of cosine. We know that if we have here cosine a plus b, we know that its identity is equivalent to cosine a times cosine b minus, okay, it's opposite, minus sine a and sine b. So using this two, this is equivalent to, we'll have here cosine of z times cosine of delta z minus sine of z times sine of delta z. That is the item we need to substitute here. So I would like to move down because we have smaller, fewer spaces. This is now equivalent to the limit of its equivalent form, the cosine, sum of the cosine, some formula for cosine. You will have here cosine z, cosine delta z minus sine of z, sine of delta z, and we still have this one here, don't forget about that, minus cosine of z all over delta z as delta z approaches 0. Allow me to rearrange the terms. I would like to place it here, so because we have a common term of cosine z for that. So what we can do here is cosine z, cosine of delta z. I'm going to place that here, minus cosine of z. Then I'm going to write this second term as my third, minus sine z, sine of delta z all over delta z as delta z approaches 0. Okay, next is to factor the cosine z for the first two terms. Cosine z, okay? When I factor that, what remains of the first term is the cosine delta z minus 1. Okay? Maybe here minus sine z sine delta z all over delta z as well as delta z approaches 0. Now, this is one rational expression. But of course, if we have here 1 minus 7 over 2, you can of course write it as 1/2 minus 7 halves, right? So with that, we can separate this into two different rational expressions. The limit of cosine z, cosine delta z, you will have here over, times minus 1, I forgot, over delta z minus the second term, sine z, sine of delta z over delta z. Okay, this is now equivalent to the first one using this idea here as delta z approaches 0. If we're going to distribute the limit notation, we can do so for the first term. Cosine of z, and you have here cosine of delta z minus 1 all over, sorry for that, delta z minus the limit as delta z approaches 0 for sine z sine delta z all over delta z. I would like to do that because here, this and this one, just like in the previous video, has equivalent forms or equivalent values. In our calculus, previously, when we have here the limit of your cosine x minus 1 over x, which stands for this, this are x's, and of course limit, you can distribute that here. Okay, this is just equivalent to 0. The second one for this item here, which again we can distribute the sign there, you will have here, by the way, this is x approaches 0, right? As x approaches 0, you have sine x over x is also equal to 1. I will no longer show you the final the derivation for this. You can visit the calculus playlist in our channel. We have the proof of this as we try to predict the values for each. Okay, so with that now, we can continue here using these values. So we have here cosine z, and the limit of that is just actually equal to 0. Minus, you will have this item here, sine z, together with this, times 1, which will give us negative sine of z, or 0 minus sine z, or again, negative sine of z. This shows that the derivative of the given function cosine z is equal to negative sine z after all of these processes intended. This is now the reason why we can now use it in some situations later on. So we still have 4 more videos on the remaining 4 trigonometric functions. But in those 4, the next few ones, we are going to use the rules on differentiation instead of the definition to make it even shorter and more comprehensible. Thank you very much for watching.